Over 100,000 people are currently waiting for a desperately needed organ transplant. Sadly, around 13 people every day will die on that wait list. Even if an organ becomes available, in some cases, those organs may only last 4 to 6 hours, creating a critical time constraint. Cryopreservation researchers bring an invaluable key to solving this problem: time. Through multiple preservation methods, they've been able to demonstrate that they can preserve organs for days rather than hours and still be viable when they're rewarmed. Key to this preservation process are cryoprotective agents. These are chemicals that allow you to preserve biological systems at extremely low temperatures without damaging the tissue. Creating these chemicals, however, is not a trivial task. In some cases, this testing can take up to 3 days or more per chemical. This timeline is deadly. Take, for example, a cryopreservation researcher who has 100 chemicals they need to test. If each test takes 3 days, or if each chemical takes 3 days, that's 300 days of testing time. During that same amount of time, nearly 4,000 people have died waiting for an organ transplant. We need faster solutions. My research focuses on applying radiofrequency sensors to create a novel, rapid pre-screening process. Say, for example, if those 100 chemicals, what if I could just find 10 of them to test that are really good before putting them through a system? That would reduce my testing time from 300 days to just 30 days, potentially saving thousands of lives. My research does this by creating sensors that can send radio signals into these chemicals and measure how they respond electrically. I can then apply them to dielectric fingerprints and see how those fingerprints compare to each other, as well as compare them to other material properties to potentially pre-screen to see if this new chemical is going to be better or worse than existing chemicals. In collaboration with the NSF-funded ATP Bioengineering Research Center, I've been able to test my sensors on chemicals made by Massachusetts General Hospital and give them each novel dielectric fingerprints. The chemists were then able to take those fingerprints and see which of the next chemicals they wanted to test for the next round, all in a matter of minutes instead of days. This system is going to apply to hopefully very much reduce the time that all of these chemicals have to be tested, saving many more lives. As I continue the research, I hope to apply it to a sensor system that can apply many signatures at once, even reducing testing time even further than I already have with the single sensor. As my research continues, this will give cryopreservation researchers a critical time boost they need to speed up to find the next best cryoprotective agent to freeze biological time and end the organ transplant wait list once and for all. Thank you.